Yeah, hi. So, so we will be seeing a problem, a coding problem, and its theoretical analysis, its time complexity, space complexity, and uh, implementation of that exact. I will be using Python for implementing. So the coding question is, say, the maximum sums that we can generate with no two adjacent elements. Say, for example, if we have been given an array of 5, 5, 10, 100, 10, 5. So the question is, what is the maximum sums that we can generate from the subset of the elements, and the element shouldn't be adjacent. Say, for example, 5, 10, 10 can be one of the possibility, which would give 25. Or if we want to take 100, 5, and 5, which would give 100, 5, 5, which 110. That is the question, and the answer is 110 is the maximum sum we can make from this array, and that can be obtained from 5, 500, 5. So that is the answer. So we will see what is the theoretical concept behind this. Basically, this is a DP problem, dynamic programming problem, and we can get the solution for this by solving small chunks of this, small chunks of the original problem. Say, for example, uh, if this is the only 5 is the only element, which is, if it is only given in the given input array, what is the maximum sum? 5 is the maximum sum. And say, for example, if you have been given these two elements, what is the maximum sum? The maximum sum would be the maximum of these two elements, because if we take this element, we cannot take this element. If we take this element, if we cannot take this element, because we have constrained that the adjacent elements cannot be taken. So in this, we can, whatever the element, that is the maximum sum is 5. Say, when coming to this when coming to this 0, 1 to second index. So in this, the possible options of the picking of the elements is 5 and 10, which gives 15. Or we can eliminate this and just take this 5, or just eliminate these two, just just take the first element. Or so finally, the maximum sum we can make out of these three elements is 5 plus 10, which would give 15. And yeah, this is the when coming to third index. When coming to the third index, so the maximum sum is, we can take the all possibilities like 5 plus 10, 15, or 5 plus 100, 105, or we can just eliminate these two, or 10, just 5 plus 100, which gives 105. So the final is, the maximum is 105, either 5 plus 100 or 5 plus 100, whatever it might be. So um, when coming to this fourth element, 10 plus 10 plus 5, that is one possibility, like 25. Or just just remove this, just don't add this in this sum, and just add up to 10, 5, which would give 105. So up to here, we can take different possibilities, like eliminate these three, just keep 5 and 10, which would give 15. Mm, and finally, the maximum sum is 5 plus 100, 105. Up to here, up to the fourth index of the given input array. This is the given input array. And finally, and just as a matter of the fact, I am highlighting, we haven't added this 10 in this sum. That is one point to consider. Mhm. So when we take 5, say for example, we haven't taken this, so we can take this element. So 5, we can add 500, 105, or 5, 10, 10, yeah, whatever it might be, the maximum sum would be 5. One thing. So we have taken this 500. So we have taken this, we cannot take this, and we can take this for consideration for calculating the maximum sum. So 505, this is one possibility which would give 110. Yeah, obviously that is the given actual answer. So, okay, so if you observe closely in this, as I mentioned previously, there are two things that we can do. Either for calculating the next element of uh, this resulting array, we are calculating, say for example, maximum sums. This is the just the name I'm giving to this array. We can add this when this element is not considered, or if this element is considered in this calculation of the maximum sum, we cannot add this. Okay. So for calculating of the maximum sums of ith index in this, say for example, I is the index, there are two possibilities I see from here. Say we can add this 5, this 105, which would give 110. I mean, the two possibilities are whenever the given input here is a positive, because we thought it was mentioned in the question, the positive inputs, only positive elements, no negative elements. That is also one thing to consider because we are approaching in that way. So the next maximum sum could be just the previous element. Maximum sums of I minus 1, or you can get some other way, like sum of add this and add I minus 2. Maximum sums of I minus 2 plus array of I. So among this, we can proceed. We can proceed we can get the maximum sums, like this is among the maximum of this we can get. So yeah, I will tell again this clearly. So how we get this formula out of this. So if we closely see this, say in this case, what happened? We have got this element but didn't get this element. We have actually added this 5, and we haven't added in the sum. So 10 is not present in 105, but 100 is present in 105. So 105 plus, we cannot add the next element because we have already considered this 100 in this 105, and we cannot consider this. So the only option we have, if this is not there, we can add this. So 105 plus 5, which is I minus 2th element, and I, if that is the biggest number, that is what written here. Or say for example, if 10 is not there, and if say for example if 10 is considered, then we cannot consider this. We cannot consider the 5th element. So if we consider this and we got this 105, so obviously we cannot consider this, and the next ith sum I ith index of the maximum sums would be just the previous element, I minus 1. That is the thing. So, okay. So this is the formulation how we using DP we try to we got it. So when seeing the time complexity and space complexity, what are the time complexity and space complexity? So we are iterating through whole array. So it would be obviously big O of n. Every iteration we are calculating the maximum sums and we we are solving the problem. So it would be big O of n, where n is the size of the input array. The space complexity is also obvious. We are building a new array of the same of the length equal to the same input array. So it would be big O of n. Okay. So this is the case. So okay, is there anything that we can enhance still the algorithm? Yes, it is obviously we can enhance. Say if we see one more time this code, in every iteration we are just calculating the I minus 2th element. Say we if we have this I minus 2, this is the I minus 2 from here, and I minus 1 is this, and we are not even using these previous I minus 3, I minus 4 elements anymore. So we need not to even store these previous elements in an array, and to make it more efficient, we can store these elements as first and second, or anything. Like we can, if you want to take I minus 2th element as second variable and I minus 1 as the first variable, we can do that. Say what I'm saying is we can save the previous element in a variable like first, and this element in a second. So and we need to update the elements while iterating. So in that case also we have the time complexity of big O of n, because we are still iterating through the whole array. And but the space complexity, because we are not going to save in a like maximum sums, we are not going to create a new array, so it would be obviously big O of 1. So this is little bit better in terms of space. uh, Now we can go to the implementation of this. First, I will implement this and later this part. Say, for example, we have this. If this is the function I'm calling like maximum sums subset, no adjacent elements, which takes the input array as input parameter. And the thing is, say for example, if we want to go with this route of maximum sums storing the values in an array, we need to set the 0 and first index elements of the maximum sums initially, because this formula calculates only elements from second index. So this is, say, mm, for maximum sums array of the first index, the first element of the maximum sums, we need to put array of 0 directly first. But maximum sums of the first element, the first index element of this maximum sums would be maximum of this and this, array of 0, array of 1. So and the next would be we need to iterate from for I in range. We already calculated the 0 1, so we need not to go for 0 1 again. Say for example in range from 2 to n minus 1, where n is the length of the array, or you can just give length of the array minus 1. You need to iterate from there. So this would be maximum sums of I is equal to, as we talked, it would be maximum of maximum sums, maximum sum of the previous element, or maximum sums of the I minus 2, I minus 2. So I minus 2, we have taken this element from this array, say for example, and we cannot take this, but we can take this. So plus array of I. This would be the maximum sum. So yeah, that's it. It will iterate through the whole given array and just return the maximum sums last element, which would be, we can tell just I minus 1 or n minus 1. So a sanity check that we can make is it's not a sanity check, it's actually a required edge case. Say for example, if array is an empty array, so we need to return, say if length, say if length of the array is equal to 0, or if not length of the array, so this length of the array, if 0 will becomes false, then if not of the false, if true, then return an empty list, which should be the answer. So this would be in the same line as this. This would be in the same line. Yeah, basically this is this will execute in the term in big O of n space, big O of n space, and big O of n time space. So as we talked, for making it big O of one space, so we need to just, we need not to save these two variables, uh, these elements in an array, and just save it in, say this is the big O of 0, so we can tell I'm storing this is in second and this is first variables, and still we need to iterate, and we need to, yeah, here this would not be an array, and say for example we can take current and maximum of I minus 1, so we talked it would be first, and this is second. So one thing here is, as we are not storing the values of the maximum sum values in a list, so we need to update these uh, first and second variables. So what happens? So we have this second like I minus 2, and first I minus 1, and current, which is the I. Say for example, if we are updating and moving forward. So the second will become the first. Second will become first, and the first will become, the current will be stored in the first. So we can just return first as the answer. So we are not storing anything, so it would be bigger of 1. Yeah, yeah, that's it. Still, this not length of the array will be present. Yeah, that's it. So it completes the problem. So we have successfully completed this.